is to prove algebraically that n cubed plus 3n minus 1 is odd for all positive integers n. So to do this, you need to split it into two separate cases. N is odd and n is even. So I'll deal with even first. And then I'm going to let n equal 2 times something, 2p, let's say. And p itself is an integer. That's very important. So I could write it like that, or I could say it in words. P belongs to the set of integers. All right, then n cubed plus 3n minus 1 is going to be, actually, it's going to be identical to, you can write equals, I think, 2p cubed plus 3 times 2p minus 1. And that is going to be 8p cubed plus 6p minus 1. So I'm actually going to get, I can take out a factor of 2 from the first two terms. But what we see is it's clearly, this is going to be even, this is going to be even, because they're both 8 is an even number and so is 6. But then I'm minusing 1 from that. But this is the clearest way to do it, okay, which is odd. I don't think you need to justify that anymore. Like that's enough. It's maybe okay, we will. One less than a multiple of 2. All right, so we're actually halfway there. Case 2, n is odd. So now we're going to let n equal 2p plus 1 or minus 1 or plus 3, but plus 1 sounds good. Okay, this one's a little bit trickier because we're going to have this triple bracket to deal with. Might just do this sort of a little bit away. So 2p plus 1 squared is going to be, okay, I will write it out. There's two double brackets. 4p squared plus 2p plus 2p, so 4p plus 1. And then 2p plus 1 cubed. It's going to be that thing. You could, in theory, do a binomial expansion, by the way. I'm just going to do it by hand. Eight p cubed plus 4p squared plus 8p squared plus 4p plus 2p plus 1. Okay, and that's just sort of there in the background. And this is going to be identical to this. Plus 6p plus 3 minus 1. Collect that together. Plus 12p. Now I can add 3. I'm actually going to add 2. And then I'm going to add another 1. The plus 1 and the minus 1 cancel. And then I can, again, take factor of 2 out of all the terms except that last one. That's why I've done it like this, just to make it as clear as possible. I think you'd get away with factorizing 2 out and just leaving the plus 3, but this feels, I don't know, because I've sort of started by saying that an odd number is 2p plus 1, I want to get it in that form again. But this is not the only way. And again, this is odd. And that's it. We've considered both cases, even and odd, and therefore we can just write a conclusion. Therefore, n cubed plus 3n minus 1 is odd for all integers n. Nice one.